Welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson, we are going to talk about the arrays data structure in Solidity. The concept of arrays is same in all the programming languages, and if you have done a programming language before Solidity, then you should have no problem in understanding the concept of arrays in this case also. So arrays are very simple data structures. Basically they are a reference type data type or data structures more specifically, which are used to store elements of same data type. So for the ones which haven't learned arrays before this tutorial, so let me explain you that arrays are actually a data structure, a structure which is used to store same type of data in contiguous memory locations. So in case, that would mean that in case you have 5 slots in the memory starting with address 100 up to 105, so in case you store first data type, supposedly an integer, in the first location, then the second integer will be stored at 101, the third will be stored at 102, and so on up to 105. So they are stored in memory, in the physical memory. They are stored, the data is stored in contiguous memory locations, and the condition is that the data type should be same for all those datas. So in an array, it can be an integer array, an unsigned integer array, a string array, a boolean array, but the condition is that the elements should be stored in continuous locations, plus that the data type for all the elements should be same. Now in Solidity, we have actually two types of arrays. One is the fixed size, which, as the name suggests, the size of that array is fixed and you define that size right at the time of the declaration of that array. And the other type is that dynamic arrays, in which case the size is not defined at the time of declaration. So the dynamic array would mean that the array grows in size as per the requirement of the program. So what is the difference? And we will be looking at the whole implementation part of the arrays in our Solidity, in our Remix IDE as well. But for now, let's understand the difference between the two types of arrays. So in fixed size arrays, basically you already know before writing your smart contract. For example, you're storing information about, the events, the upcoming events. In case you are very sure that, in your smart contract, that if it's a fixed kind of event, that there are only going to be 10 events on the smart contract which you're working, so you can at the time of declaration say that the array is going to store value integer values which will have event IDs, and it will be 10 in number, that is fixed. So that will come under the category of fixed sized arrays. But lot many times, in fact, in practically most of the cases, you do not know, you're not sure about the exact size of the array at the time of the declaration. So there are use cases wherein you depend upon the dynamic nature of the arrays, and so in that case you need to have those dynamic arrays where you are just defining that I will be storing integers, event IDs which will be in integers in this array, but I do not know how many events can the smart contract have. So for that you use the dynamic arrays. So we'll be looking at both these arrays in our remix. So now, as you can see that in the remix IDE, I have already mentioned the contract name to be arrays, and I've written the license line and the Solidity version line. So now let's write our code. First, let's discuss the fixed size arrays. For that, as I've discussed the syntax with you, I'm writing an unsigned integer and I'm marking the size to be 4, and then I am saying public, the visibility should be public, so that a getter function is created in our remix ID, and I write the variable name to be my array maybe, and then unless I don't declare anything and I just save this. So you see, when the moment I save it, a green tick has appeared. That means the contract has compiled successfully. So now let me just deploy it and show it to you. The moment I deploy it, so you see that this has been created. The getter function has been created with my array name. And you can see that it is asking for some unsigned integer. So this is nothing but the index value. So it is going to ask you that which index value you want to get, because it's a getter function. So for example, I put index 0 here. The moment I click on it, the value returned to me is 0, which shows you that the default value 0 has been set. The moment you wrote 4, so Solidity has created an array with the name myArray and stored zeros at 4 places. So in case I write index 2 here, again I get a 0. But in case I write index 5 here, you see there is an error which has been reverted on the in the console, that this cannot that this transaction has been reverted because this is out of bound. So obviously you cannot access an index which is more than the size of the array. Now let's declare it and see. For example, if it's 4, let me make square brackets, right, 10, 20, 30 and 40, and save it. Again, you see it has compiled successfully. Now if I deploy it again and show you maybe the value at index 1, so you see 20 has been returned. So now so this is how for each indice this value gets stored basically. So now one thing you have to take care is that we have learned that since this is a state variable here, we are declaring it at contract level. So initialization at the time of declaration is possible, but you cannot do something like you just declared it here and the next line you want to initialize it. So in case you try to do something like that, where you are doing something like this, so you see this, it will give you an error that this was not expected. Since in state variables you can either declare the variables here at this time, or then you can use a constructor or a function to initialize the values. Even that is possible. So let me just quickly show you. In case you want to write a function, add value, maybe you want to mention the index and the value for this, and you want to make the function public, then okay, one second, yeah. So then my array, and I'm saying that at a particular index the value which you have passed should be value. Okay, that's it. Now you see it has compiled. What I'm doing in this function is, so you need not worry about the syntax of the function. We'll be covering it when we are discussing functions. For now, I'm just writing a function which is taking two inputs, an index value and the value to be placed there. And I'm referring my array function, array. And in that array, I'm at that particular index, I'm putting this value. So now if I have compiled this, now let me deploy this. So the moment I deploy this, so let me show you. So right now, if you check, first of all, you check at index 1, maybe you check what is the value being returned. The value being returned is 0 because that's the default value. But in case at index 1, I pass a value to be 23 maybe, and I click on add value. Now when I check my array, at index 1 you can see that 23 has been returned to me. What do you mean by this? That the at the index 1 the value of array is 23. And how did it come there? Because I used a setter function to set the value at that particular index. So obviously you have to take care of the size of the array. It should not exceed, otherwise it will give it, the transaction would be reverted and it will give you an error. And now there is a function in the arrays which is known as the length function. Let me just show it to you. So get length is the name of the function, and get length will not accept any parameters. It will be public, and since we are reading a contract state variables value, so we have to write view. I will explain in detail about view concept in our upcoming videos. Returns, it will return an integer obviously, and because the length would be an unsigned integer. So now I just need to return my array dot length. Dot length is a function, is a method by default present in the Solidity language to check the length of an array. So the moment I do this, I compile this. Let me deploy this. So see, now this array, the moment I click on get length, you get the length to be 4. So now this is one very important point, that you might have assumed that since Here I have not declared dot initialized the array, so it should be null and the length should be returned as 0. But as I told you, in Solidity there is no null. So the moment you said 4, Solidity placed 4 zeros in your array. So the size is 4. So when you are asking for length, it is going to return you 4 and not 0. Okay. The values can be changed, can be updated from 0 to something else using this function where you reference it through index, but it will not, the length will never be null, it will be 4. So that's it for fixed size arrays. Now let's see the concept of dynamic arrays, right? For that, I'm again declaring an array. Here, I am declaring an array and with an empty square bracket, meaning it is a dynamic array. I'm giving it public. Let me name it dynamic array like that. Okay. So now to add a value to this dynamic array, okay, there is a special function which is called as the push function. So because here you have just declared this array, right? So how in dynamic array you are not supposed to know the length of the function. So first of all, yeah, let me just tell you that add value is going to be a function which is going to add a value to the dynamic array. So in array, what you can do is that in case you want to add a value, you can just use dynamic array dot push. That is a function. Let me push value 10 here. Okay. And get length is the same, that it is used to get the length of the function. So what is the difference between a fixed and a dynamic array is that here, in case you haven't pushed any value, the length of the dynamic array will be returned as 0 because you don't know the size. Okay, it is an empty array in first in the initial condition. The moment you push an element, the length increases to 1, length increases to 2 again, to 3 again. So that depends upon the basically the length, the values we are pushing it. So now we can also do one thing. Let me just write an index over here, sorry, value over here, and replace this by using the value button. We are going to push a value using this, and we are going to remove a value by using another function which is called remove value. Okay, and for that you should know that we are making it public. And here in the dynamic array there is a function, third operator, which is known as the pop. And as you know that push will add the value at the last of the array, similarly pop will remove the last element in the array. So please remember that pop is going to remove the last element in the array. So now let's compile the whole. So there's a problem in my syntax. Yeah, sorry guys. So I have to put round brackets here. Okay. So yeah, now the smart contract has compiled successfully. Now let me deploy it again. So as you can see the last iteration here. So now in case you want to check the length of the dynamic array, initially it is 0. So let me add a value 10 to, so let me click on add value. The moment I added the value, now if I get the length of the value, you see the length has changed to 1. Even if I put the index 0 of the dynamic array, I am returned with the value of 10. Okay, because now the length has changed to 1. Again, now let me put another value which is 20. Let me click on add value. Now if I try to get the length, you see I am returned with value 2 since 20 has been added. So what are we doing in add value? We are pushing a value. So we passed 20, now it has been pushed and the length has increased to 2. Similarly, let me push 30 again, and now if I get the length, now it is 3. And if I try to see the element at index 2, I see 30, which is fine. It is working completely fine. Now I want to remove the last variable. That means the 30, the value 30 I want to remove. Now let me click on remove variable. The moment I click on remove variable, the element has been popped using this function pop. Now let me check the length. So as you can see, now the length has changed to 2. Okay. Again, if I just remove the variable and again if I will check the length, I will see the length has reduced to 1. So that is how pop function works. It removes the last element of the array and it reduces the length of the array. So this is about dynamic arrays.